Listen to part of a lecture in a geology class.
Beginning in the late 1960s, geologists began to uncover some evidence of a rather surprising kind when they looked at various places around the world. And what they found out when they examined rocks from about 750 million years ago to about 580 million years ago, they found that it seemed that glaciers covered the entire surface of the Earth, from pole to pole, including the tropics. How did they come to this astonishing conclusion? What was the evidence for this? Especially when glaciers today are found only at the poles or in the mountain? Well, basically, when glaciers grow and move, they leave behind a distinctive deposit consisting of primarily, at least on the top level, of ground up little bits of rock. They almost look like rocks that have been deposited by streams, if you've ever seen those. And that's caused because, although the glacier is ice, it is actually flowing very slowly. And as it moves, it grinds the top layer of rock. It breaks off pieces and carries them away. So when you have glaciation, you have a distinctive pattern of these pieces of rock, which are called erratics. Erratics are rocks. They're the stones that are often carried long distances by glaciers. So in the 1960s and onward up through the 1990s, we keep finding evidence for glaciation no matter what the latitude, even in tropical latitudes. Now today there are glaciers in the tropics, but only at very high elevations. But 750 million years ago, apparently there were glaciers even at sea level in the tropics. How could this have happened? Well, first, the growth of glaciers benefits, if you will, from a kind of a positive feedback loop called the ice albedo effect. With the ice albedo effect, glaciers, because they're white, reflect light and heat much more than does liquid water or soil and rock, which are dark and absorb heat. So the more glaciers there are, the more heat is reflected. So the climate gets cooler and glaciers grow even more. However, normally on a global scale, there is a major process that functions to curb the growth of glaciers, and that process involves carbon dioxide. Now, we're all familiar with the notion that carbon dioxide is what we call a greenhouse gas. The more carbon dioxide there is in the atmosphere, the more heat the atmosphere retains. That's what a greenhouse gas does. So the greenhouse gas effect is kind of the opposite of the albedo effect. Now, as it happens, when silicate rocks, which is a very common class of rock, when they're exposed to the air and to normal weathering, they erode. Carbon dioxide is attracted to these eroding rocks and binds to them, forming calcium carbonate. Calcium carbonate is eventually washed into the ocean, where it settles to the bottom. This process, this forming of calcium carbonate, has the effect of sucking the carbon dioxide out of the air and storing it at the bottom of the ocean. Now, follow me here. The process that's sucking carbon dioxide out of the air, keeping the greenhouse gas levels low, cannot happen if the rock is covered with ice. So, while glaciers reflect light and heat, cooling the Earth, they at the same time cover rocks, so there's less calcium carbonate formed, which leaves more carbon dioxide in the atmosphere. Higher levels of carbon dioxide keep the atmosphere warm, which slows the growth of glaciers. So it's a balance, and the glacier growth remains pretty much under control. Now, what happened 750 million years ago to upset that balance? It seems a relatively simple explanation, actually. 750 million years ago, all the major continents are rocky, bare, and pretty much lined up along the equator. They hadn't yet moved to where they are today. So what happened was perhaps a slight cooling of, the very slight and temporary cooling of the sun, which still happens from time to time, and the Earth starts to cool. The ice starts to spread on the oceans, starting at the poles. Now, by the time the ice reaches about 2/3 of the way to the equator, it's too late. See, because the continents are the last things to be covered by the glaciers, they continue weathering, The rocks keep eroding and the carbon dioxide levels keep falling. So the ice albedo effect from the glaciers is increasing in strength, while the atmosphere continues to lose its ability to retain heat, making glacier growth unstoppable. Now you have what's called a runaway freeze. And for perhaps as long as 50 million years, possibly with some interludes, the Earth was frozen from pole to pole, like a giant snowball.